Today's video is all about the worst casting I've ever made. You probably remember about 2 videos ago where I was picking on a commercial foundry and pointing out their faults. Well, I thought it was about time I should show you one of the castings that I've made, and it's really bad. Here is a view of the top side of the casting, and you can have a look at it. I can hear you say, well, what's so bad about that? You could probably only see one little flaw. There's a little blowhole just there. Wait until I flip over the casting, then you'll see exactly what's happened here. Here is a close-up view of the other side, and we'll rotate it around a bit. And as you can see, there is no shortage of blowholes on there. I mean, they are everywhere. I'll have to get another view and show you just how bad it is. Here is another view, the side walls, what you couldn't see with the other view, and I'll rotate it around for you. As you can see, there's no shortage of blowholes. So you're probably wondering why there are so many blowholes in this casting. Well, it's a long story and I'll try and cut it short. Back in the day when I used to run the cupola, at the end of the melt I would just drain the iron out of the cupola and pour pigs or ingots. Now I had a friend who used to give me a hand, and he used to say, what a waste. You could be pouring it into a sand mould and make useful castings from it. But I remember reading in the old books, and they said when you are finishing a run with a cupola, you don't make important castings, especially when you machine them. But they never really said why. So the next time he came around, he brought some sand that I had given him. Now I'd run out of sand because I need every bit of sand with a cupola because it can melt so much metal. So he made up the mould from the sand I gave him from a few months back, and at the end of the run we poured this casting, and as you can see it was really bad. And now I can see why you don't use that metal from the end of a run, because it does cause problems, and I'll go into it and I can pinpoint 3 reasons why it does happen. Here is the first reason why there were so many blowholes in the casting. What happened, after a while my moulding sand gets a lot of dead coal dust and burnt bentonite, and what happens is it accumulates in the sand and it blocks off the pores. But what happens is it also makes it unworkable. So what happens is you put a lot more moisture into the sand than I normally would put, and yeah, it's just too wet. That's all I can say. It's just too wet and the steam won't escape. And this is what he made up in that mould, and I said to him it was starting to cause blowholes in my castings, and I said I was going to throw it out, but he said no, give it to me. So I gave it to him, and it was quite a lot of sand, and this is one of the results there. This is one of the things that beginners don't realise, that sand wears out. It tends to lose its porosity, and what will happen also is that you tend to put more moisture in, and the sand feels still very dry, but it still has too much moisture in it. And what will happen is, as you'll see, the metal rests on the sand surface and it produces a lot of steam, and you'll get these blowholes. And he told me when he machined this, it wasn't any blowholes until he got down to about 1 millimetre in depth, and then they started appearing, and they just got worse and worse. Here is my rough and ready drawing of the sand mould that he made up. You can see that's the cavity left by the pattern. So you got one box at the bottom with the green sand core, another box on the top, and then what he's done, he's put an extra pouring bush so to give it a lot of height and I poured it through that way. But the problem is with that, at the end of a cupola run, the metal is cold. It's not as hot as it could be. The problem is it hits that. It's a bad idea to hit that sand core, and it bounces all over the place into little droplets and it refuses together. But also that sand had too much moisture in it. So pouring it down through there is okay if you've got really hot metal. But what happened was it wasn't hot, and when it came through there, it scatters into little droplets and refuses again. But also what happens is the sand is very wet, and just under that surface there, the steam starts to come through and it creates bubbles. Now if you had a poured hot metal down there, it would have worked quite well with good sand. But what happened a week later when he showed to me, I ended up firing up my oil furnace and I poured it this way. I made a little sprue coming down here so it doesn't have to fall very far, and then it goes in here and then to the bottom and then fills up the mould. In this part of the video we'll have a look at this book. It's called Grey Cast Iron. It's about the general manufacture, structural metallurgy and engineering and physical properties. It is written by John W. Bolton, the chief chemist and metallurgist, Lukenheimer Company, Cincinnati, Ohio. And if you want to have a look also, it's published by the Penton Publishing Company, Cleveland, Ohio, 1937. This is a really excellent book about all the little ins and outs about cast iron metallurgy and the problems you can encounter. It's a really good book to have a look at. So here we are on page 145 in the book. Now this is a iron sulfur phase diagram, and with the varying percentages you'll see below there, it goes from 95% iron to 5% sulfur, and you go the other way where it's high sulfur and low iron. Now what I'm trying to get at is, you look up here and there it is, you've got two liquids, then you've got a solid solution and a liquid. And when you go across to here, it's 1400 degrees C and above when you want a liquid. See, it says C just there. Now why am I going on about this? Is because cupulas run off coke, and coke can have sulfur in it, and the coke that I use tends to have probably a bit too much sulfur in it. That's not a problem in itself. What happens is you need to have a very hot metal to pour, and you won't get those blowholes. If you pour it too cold, the metal is very sluggish with a higher content of sulfur, and it'll cause you endless problems, as you saw with that casting there. So this is why you have to have really hot metal. And when you go across to here, you'll see the melting point rises up a lot. There's one thing about this phase diagram. It's only showing iron and sulfur, but a normal cast iron has carbon in it, silicon, and as well as phosphorus, and it can change those melting points. But the main thing is, what I'm trying to say is that sulfur can raise the melting point of cast iron and make it very sluggish. After reading that book, I decided to go and buy some analytical grade iron sulfide. Now here it is, it gives you an idea of the size. There's not much there. That's from a jar full of it. So what happened, I decided to melt some cast iron and get it really hot, and I could see that it was very fluid, clear on top, and added this iron sulfide in there, and within 2 seconds it went from a very fluid iron to a very sluggish iron that just sort of wouldn't move around. So what happens is sulfur does raise the melting point of cast iron. That's not a problem in itself, but you must have really hot cast iron to pour it. And if you've got a really thin casting and you can't get it hot enough, you are in real trouble. Just thought I'd show you another interesting graph on a page 155 in the same book. You see where it says the effect of phosphorus on the melting point. So when you come up to here, you've got the maximum melting point for that 0% phosphorus, and then when you come to 6%, you can get the melting point of cast iron to around about the melting point of brass, but when you add more than 6% it starts to rise again. So it's very interesting, these graphs, if you want to change the melting point of cast iron. And that's what I did in one of my previous videos, is that I'll drop the melting point of cast iron to pour some lace. Cast iron lace is very difficult to do unless you have a lower melting point iron, and it fills up the mould. So to recap, if you've got a metal that's very cold from a cupola and it's got a higher sulfur content, it's very sluggish, you will get problems with those blowholes. But combined with that, if you've got a sand that's got very little porosity in it, it will bubble through the metal itself. But also, if you pour from a great height like that and it spreads out, the same problem will surface. But like I'd like to say is, when melting with my furnace, oil furnace, I've never had this problem because I always get hot metal and there's no sulfur contamination. So if you're going to use a cupola, these are some of the things you've got to look out for when you're casting cast iron.